Hey, welcome back to Fat Mama Physics. In this video, we're going to talk about subtracting polynomials after we've done adding polynomials in our last series of lessons. So subtracting polynomials, the key in here is to make sure you flip signs, and we'll talk more about that later. But of course, the company board game that I have is related to that. Also, one of my personal favorites when it comes to party games, where more than many people are involved. So let's show us what that looks like. Alrighty, here I have the board game set up. It's actually not much to begin because things get explored over time. And here is the board. Actually, let's zoom out. Here is the box, and we have the legacy version. We also have the original version. The legacy version is essentially a series of campaigns in which we have 4 people. We just play through it, and we're done the campaign. So now this board game can be used as the original version, just as any old party game. And but the rule set is a bit more straightforward. It cleans out some of the misunderstandings in the previous series. So I like this a lot better. We all like this a lot better. So what is this game about? This game is about you exploring a haunted mansion and trying to figure out some secrets or whatever, try to solve a mystery, whatever it is. But essentially, you go through, you explore these tiles, things happen, you get items, you might get omens and events, your character levels up or whatnot, and then something bad happens. There's always something bad that happens. So let's talk about that as we move along. Okay, so notice each character has their own set of traits, their own stat chart. So for example, this guy, let's zoom in here. And he has so there's 4 stats: knowledge, sanity, speed, and might as we go around clockwise. And every character has a base stat and a growth and their growth is different depending on their character. This guy's sanity tends to grow very, he starts out with a lot of sanity and it goes up very quickly, unlike some of his other traits like knowledge and might. Looks pretty weak. But also there's some buffers depending on which character it is. Anytime one of your stats goes into a skull, then you die. And this happens after the haunt begins, and talk about the haunt in a second. So every character, the growth track and the starting stats are different for those, just to make everyone a little bit different and make the game a little bit more fun that way. And as these characters, we all start on the entrance. There are some additions in this game that's more than the base game, but I'll just talk about the very basics. On any given turn, let's say purple goes first, they move. So they move based off of their speed. So purple has a speed of 4. He is going to move 4 steps. So he can explore anything he likes. So if you take a look, there's the front steps, which is adjacent to this is upside down, but the entrance hall. And this is the hallway, this is the ground floor staircase, which then these staircases lead up to the upper landing, which is the 2nd floor. There's also one more tile, which no one has access to until you explore things in the other tiles. So this purple guy has a choice. He can do, let's say he's going to stay on the bottom floor. So he's going to go 1 and then 2. And then he'll have to explore this tile. And here are a stack of tiles in which he needs to go from the top and pick the next one that is a legal placement. So this one here can represent the ground floor, so he can take this tile and then he reveals it to be a master bedroom. And very fitting. So notice on any given tile there's a name and there is a symbol. The symbol tells you what you need to do, usually which card you need to pick up. So here are the different symbols. You have an event, omen is the crow, and the item is the ox symbol. So he's going to take an omen from the omen deck. So here it is, that's his omen. He reads it and he does whatever it says here, which is not the important part of this game. So I'm just going to put it here. Let's say he did it. But what happens now is, I promise I didn't stack this, but he gets to make a hunt roll. Okay, the hunt roll is essentially what triggers the midpoint of the game where what I said something bad happens. So here's the what is a hunt roll? So there's some dice over here. He's gonna roll. The number of dice he rolls is determined by how many omens that are currently in play. There's only one in play, so he only roll one dice. So, of course, he's going to roll, and of course, he's not going to get a big enough number. The dice here only has pips of 1, 2, and 0. So, in order for a hunt to trigger, any person rolling the dice must get 5 or higher. And the only way to get 5 or higher, the minimum number of dice needed is at least 3 to get a roll of 5 or greater. So the hunt's not going to begin very soon. So what I'm going to do is I'm going to pretty much play through the game a little bit and just show you kind of what a midpoint in the game might look like. Okay, so I've placed a few more tiles, and I've actually tried to find the ones with the omens so that I can progress the game a little quicker. So the most recent reveal is this guy. He went to the stable, and then there was an omen. This guy is green, so he did get an omen card. There was another omen that was revealed earlier, so this is the yellow dude. The yellow dude also got an omen, so now this green guy is gonna make a hunt roll with 3 dice since there's 3 omen cards. So let's say he rolls a 5, which is very hard to roll considering the probability distribution of these dice. But let's say he rolled a 5 perfectly. So this is where the hunt begins. When the hunt begins, then what happens is we take a look at ruling. So let's see. The person got the omen, which is the Christ of summoning, and he found it at the stable. So then we look at a matrix here in which what is this? This is the stable, and he found the what is it called? The Christ. So that's 43. Okay. Ooh, that's interesting. Technically, I shouldn't be revealing this to you. So what happens is he looks at this matrix and he goes through this list of who is going to be the traitor. Haha, so someone in here turns traitor. So sometimes it's a hunt revealer, so it could be him himself. Sometimes it could be the youngest player, or it can be someone with the highest knowledge or the lowest sanity or whatever. In this one, it looks like there's a hidden traitor in which there's some special rules. So again, so then when that happens, let's say someone turns traitor, then the good people, the protagonists, take the secrets of the survival, and then they go and read whatever section. This is hunt number 43 or whatever. So they read this, and then if there is a traitor, then this traitor reads the traitor's tome, which is going to be 43. So age 12 plus. You guys are 12 plus, right? I'm just kidding. So here we go. He goes to 43, and then this person will read 43, in which there's none in this case because there's a hidden traitor. But that's what happens. So notice, so the mechanism of this game is when the hunt begins, someone turns traitor. That person flips side, goes to the other side, goes to the dark side. So that's kind of the essence of our lesson as well, is that we'll be flipping signs, just like we'll be one person here will be flipping a side. So yes, it is very fun, and then pretty much becomes a traitor versus the protagonist, and there's some battle scenes. There might be stealing. There's all sorts of interesting mechanisms that happen. So here we go. This is Betrayal on House of the Hunt. I think there's a lengthier name there, Betrayal on House of the Hill or something. Very fun and a great party game. So thank you for joining me with Betrayal, and we'll come back to our lesson. Okay, so here we go. Let's talk about subtracting polynomials. So talking about flipping signs, let's go through an example of what this would look like. Again, every polynomial is going to have its own set of brackets. So starting with the first one, notice there is no sign in front, so everything here is assumed to be positive. So if I remove the brackets or dissolve it, I get 5x plus 3. That doesn't change. But what I have now is I have a negative sign, and I have to apply this negative sign to every term inside. Think of it this way. Think of it as I have a -1 in front of my polynomial. So what that means is I need to multiply everything by -1. That is effectively saying that I'm going to flip all the signs in front of each term, which means if I had I have a 3x here, assuming that's a plus and this is a minus, then I'm going to get, instead of a plus, I'm going to get a minus 3x, and then this -2 is going to flip into a plus 2 instead. So this is exactly like adding polynomials, except I have to flip all the signs in the polynomial that is being subtracted. That is the one to subtract. Okay, so after I rewrite that, then I can go ahead and identify my like terms. Don't forget the negative signs, and then go ahead and rewrite my my statement basically. So I have 5x minus 3x, and then I have plus 3, and then plus 2. So hopefully now the identifying like terms is easier for you, that I can start to do things a little bit faster. Okay, so I get 5 minus 3 is 2x, and 3 plus 2 is 5. So I get 2x plus 5. That is the horizontal method. And I think that is it. That is the only example here. Remember in the previous video, I said that if you like the vertical method, you just have to be very careful when you're dealing with subtracting polynomials. Because take a look at this. How they've set it up here. In the vertical method, you line the one at the top and you line the one at the bottom, but you can't just go down and just and add them up, because what you're trying to do here is you're trying to subtract. Okay? So you kind of have to go, what's 3 minus -2? And to visualize it, it becomes a little bit trickier, or it just isn't as intuitive. So I don't prefer the vertical method in this case. What you could do, if you really love the vertical method, is you could, instead of doing it this way, fine, I won't put a cross. You could do it so that when you are writing it down in the vertical way, you can convert the signs of your polynomial, the second one, when you are writing it in the second row. So I'm still going to imagine so effectively what I'm doing is, I won't write that, I'll confuse you, is I'm going to flip these signs as I'm writing it down. So for example, minus 3x, okay? And then minus a -2, that's going to make it plus 2. And then I can treat this as an addition statement instead. Okay, so then I just add top down. 3 plus 2 is 5. And then 3 plus -3, 5 plus -3 becomes 2x. 2x plus 5, which is exactly what I have above. Okay, so if you want to use if you love the vertical method and you want to make it easier, this is one way I can suggest to help you with that. Okay, but I will continue using the horizontal method in these videos, just so I'm just advocating for clarity and just ways to help reduce the confusion, just in case you make silly mistakes. Okay, so let's see here. Whoa, that's copied very poorly, but let's begin. Example 2, find the difference and then check your solution. Okay, so, oh, wait, that was one thing I didn't show us, is how to check your solution by adding the difference to the second polynomial. So how to check your work is the following. How to check is, if I have my answer in green, I take my green and I add the second polynomial without the minus sign, so just this guy, and I add it just to see if I get my original polynomial, which is the 5x plus 3. So if I add this, I get 3x plus 2x. This is 5x. And then 5 plus negative 2 is plus 3, which is my original. Then I check that off. So let's do that for example 2. So I'm going to do the horizontal method here. Okay, so I'll rewrite this after breaking apart the brackets. So I keep everything in the first polynomial the same. In the second one, I flip the sign, so that becomes plus a squared plus 3a and then minus 2. Then I can group them together. I can group my like terms together. So let's put the greens together. So I get minus 2a squared plus a squared, and then blues, I get plus a plus 3a, and then last but not least, minus 1 minus 2, and then ultimately I get minus a squared minus negative 2 plus 1 is negative 1, and then plus 4a here, minus 1 minus 2 is minus 3. That's my final answer. Okay, I can check by taking this and adding the second polynomial that was being subtracted. So this guy, which is so hard to see now, but it looks like that's going to be negative a squared minus 3a plus 2. So let's say if I added these together, am I going to get my original? So minus minus, I get negative 2a squared, plus 4 minus 3, I get plus 1a, minus 3 plus 2, that's minus 1. So hey, that's exactly the what I had before, so this checks out. So that's how we check our solution. Okay, so next up we have examples A all the way to C. Guess what? I'm gonna ask you to try that out. And then maybe in my, let's see, yeah, my last video, I'll do examples 4 and 5. Okay, so that'll be a short one. So good time to pause the video. Try example 3A all the way to C. Good luck. Okay, so let's do that. Find the difference and then check my solution. Okay, so we'll do this right now. I get negative 3w minus 12. Flipping the signs, I get plus 9w and plus 6. So I'm going to actually do this a little bit faster now. Okay, so minus 3w and then plus 9w. Okay, since they're like terms, I'm going to get plus 6 as a result. So that's 6w. Next up, I have minus 12 and plus 6. That's going to give me a total of negative 6, which is my answer. So to check, I can do this one, plus negative 9w minus 6, that's my second polynomial. And if I do that, 6w minus 9 is going to give me negative 3w, minus 6 plus negative 6 is going to give me negative 12. Okay, and yes, it gives me the whatever I had to go to start with, so therefore my answer is correct. Next up to B. All right, so with B, I have negative 3n squared plus 9n plus 7. Okay, so flipping all my signs, minus 2n squared plus 4n and then minus 13. Okay, notice there's a lot of signs to flip. Just to be careful, you got to flip every sign. Okay, sometimes my students just do the first one and forget the last two. All right, so let's combine things together. The n's go first, so minus 3 and then minus 2 again, I get minus 5n squared. Okay, then I get the 9n and then the 4n's, which added together gives me 13n. Last but not least, I have plus 7 minus 13. That's going to give me minus 6. Okay, so there we go. There's our polynomial. And if we add the second polynomial that's being subtracted, we should theoretically get our first one. So doing that, minus 5 plus 2 is minus 3n squared. Plus 13 minus 4, that's going to be plus 9n minus 6 plus 13, that's going to give us plus 7. And this is exactly what the first polynomial is, meaning our answer is correct. Whew, last but not least, number C. So let's rewrite this out. Negative 14 plus 3g squared plus 2g, okay, flipping our signs, plus 5g minus 10, and then plus 7g squared. Okay, so let's identify our like terms, starting with the highest degree. So 3g squared and 7g squared, that's going to give us 10g squared. Next up is our 1 degree, 2g and 5g's, that's going to be 7g's. Imagine we achieve that with our internet, be crazy. Minus 14 and minus 10 is going to give us a total of negative 24, which is our final answer. And then, of course, we can always add our second polynomial to check if we're on the right track. So if we do that, we're going to get, let's see, I have negative 7g squared and 10g squared. We add those together. That's going to give us 3g squared. And next up we have 7g and negative 5g added together. That's going to give us 2g squared. Sorry, 2g, not g squared. Negative 24 plus 10 is going to give us negative 14 added together. So we double check, minus 14 plus 3g, yes. Okay, plus 2g, there you go. Therefore, our answer here is correct. All right, so maybe I will summarize some takeaways. Key thing here is to make sure flip all of your signs. Okay, so after you flip all the signs in your second polynomial, then everything, whatever you have remaining, just becomes an addition statement. Okay, so that's basically key steps. And of course, you reorganize, do what you need to do there. Okay, so that's essentially, after you flip the signs, you just end up with adding polynomials. Okay, so I'm going to conclude that video there. The last video, I am going to do examples 4 and 5. So thank you for watching. Stay tuned. Fat Mama Physics signing out.